Hello everyone. How are you guys doing today? Can you guys hear me? Thank you. I'm doing good. Thank you, Kimberly, for asking. It's a little better. Yesterday I had two classes at Baruch. It was near my home. So I was like, oh, let me just go there because I don't have to walk. It's near my home. I just had to get on the bus from in front of my home, and then I'll get off in front of Baruch. So I don't have to walk far. So I came, and then I had two classes, and then after my classes, my foot was feeling so painful. I was like, oh man. And I didn't walk. Still, I had that much pain after my classes. So if I go to Hunter, where I have to walk from the East building fast to the West building, and then I have a class in there, and then from West building, I have a class to the North building. So I was like, I'll go crazy because after the class, I had to come back to East building from the North building, and then take the bus from after walking one block. I was like, oh man, let me just take it online and try to be safe. Okay. That's why. Again, I'm sorry for being online, but I'll try my very best to teach as easily as possible so that even if you're online, still you'll feel like you're being in class. Okay. And today's material will be fun. It's not hard. I hope you answer all the questions I ask you. And if you have any question, ask me without any hesitation. In that way, whatever you don't understand, I'll be able to help you here to understand them instead of for you to struggle alone to understand them. Okay, guys. Any question, comments, concern, complaint? Nothing. um, so I posted all the lecture notes on Brightspace under pre-lecture notes tab. So you can read the lecture notes, but they don't have any completed questions. Okay, so I have only questions there, and the solutions of all the questions there are on your notebook. And if you are absent, then you can find them in class recording. So previously we learned about the power rule of antiderivative. And we said in order to find the antiderivative of any polynomial, it's we add 1 with the power, and then we divide by the sum. And we put a constant because when you take the derivative, its derivative of a constant is 0. So the function given to us, we don't know whether we have a constant in the original function or not. So since we don't know that, so we put a C just as a placeholder so that we can see like maybe the original function has a constant which has a derivative 0. That's how that's where the C is coming from. It's any constant, maybe in the original function. So if f is the original function, we know f prime is its antiderivative. And sorry, this squiggly thingy of f is antiderivative, and s prime is its derivative. Now, let's say we have f of x as, let's say, x squared plus 3. So its derivative, we already know, it's easy, 2x plus 0. Now, if you want to take the antiderivative of this derivative, the antiderivative and derivative, they cancel out. So we're supposed to get the original function back. Now look at here, sorry, this function. This simply becomes 2x, right? Because there is nothing. So when you take the antiderivative of 2x dx, we get, by the power rule, we add 1 with this power, so we get 2, and then I divide by 2. So 2 cancel out, we get x squared. We're supposed to get the original function back, but look at the original function. It's x squared plus 3. Yes, Raka, I'm talking. It's x squared plus 3. But look, what do we get? Only x squared when you take the antiderivative. So see, we are missing this plus 3 in the original function. That's why in order to make sure that we are not missing anything, we put a plus c when you take the antiderivative. Now, power rule is a very convenient rule. We can find antiderivative of any polynomial using the power rule. Or it doesn't even have to be polynomial. It can be any negative power, fraction power, decimal power. We can have a function with any power that is a single power. We can use that. We can apply the power rule. However, we cannot use this power rule for every other function. For example, if you have a function like this, the power rule doesn't work because we have two functions together. One is 2x and one is the square root of 5 plus x squared. So in this case, we cannot use power rule. And like derivative, see, when you have a multiplication of two functions, we use the product rule for the derivative. But antiderivative doesn't have any product rule, unfortunately. So instead of using antiderivative, instead of using any type of rule, like any type of product rule, since we don't have any, and we are not allowed to use the power rule, so we look for a different rule to make our life easier. And the name of this rule is substitution rule. We call it integration by substitution, or the U substitution, or the reverse chain rule. All this means we are using a substitution to find the antiderivative. But this method also is only for a limited number of functions. Only if we have a specific characteristic given in the function, only then we can use U substitution. So how do you use the U substitution? The first thing you have to see is that in the function given to us, do we have a derivative given to us? So we're supposed to have a composite function and then derivative of the inner function of the composed function. If we have this characteristic in our function, only then we can use this substitution. So what we do is we take the inner function, which derivative is given, and we let this function to be u. So let's say this inner function is u. And we already can see the derivative of the u is given. So derivative of the gx is derivative of the u. And what we do is du, yeah. So what we do is in the substitution, we substitute this gu with u and this entire derivative and dx with du. So we get one function, f of u du. And then we take the antiderivative of f function. Once you take the antiderivative, then we substitute back the u with the original function, and we are done. Example. Let's say we have cosine x squared 2x dx, and we want to find the antiderivative of that. So if you observe, derivative of cosine is not given. That means cosine cannot be u. Now look at the next one, x squared. If u is x squared, then du is 2x dx. This is given. That means our u is the inner function of cosine. So we rewrite cosine x squared as cosine u, and then 2x dx as du. And now we know how to find the antiderivative of cosine. Which function has derivative of cosine? Well, that is the antiderivative of cosine. So we know derivative of sine is cosine. That means antiderivative of cosine must be sine. And then plus c. But then the original function doesn't have any u. So we cannot have u in our solution at the end. At the end, we must convert our u back into whatever we let u to be. So it's sine x squared plus c. And this is our antiderivative of this weird looking function. Not weird, like hard looking function. Now, the hardest thing here is figuring out what is u. So you can figure out u by observing du. U must be that thing, whatever's derivative is given. So the du must be alone. It cannot be inside any function, but it cannot be on the denominator. If you can find a derivative, if you can find a function that is not inside a function or not in the denominator, and it's kind of looking like a derivative of some function, that means that's the du. And based on the du, you can figure out your u. Any questions so far? No? Okay, I already did that. So let's do some example. We are given x cubed 3 plus x to the 4 whole thing to the 7. Now I said du cannot be inside any function. That means this thing cannot be du because this is an inner function. Outside we have the 7. Since this thing cannot be du, so this must be our u. If you let u to be 3 plus x to the 4, that means if du is 0 plus 4x cubed dx, which is same as 4x cubed dx. And now look, we have x cubed. So at least some portion is given. So what we do is we rewrite this. We write 3 plus x to the 4, 7. And then see x cubed dx, they have to be next to one another. So we put them next to one another. Now in our function, we can only see x cubed dx. There is no 4 in the function. So we need to divide both sides by 4 so that we have this thing alone. And then we replace. So we have this thing inside is u. It has a power 7. And this whole thing here is du over 4. Now this 4 is a constant, so you can pull it out. So you can write 1/4 antiderivative of u to the 7 du. And now this is easier because we can use power rule here. If you use power rule, we just need to add 1 and then divide by the sum. So 1/4 u to the 8 over 8, and then you add a constant. So these two are on the denominator. We multiply them. We get 1/32 u to the 8 plus c. But we cannot stop here because what is u? We didn't start with u, so we cannot leave the answer with u. We must substitute our u back. So 1/32. Our u is the inner function 3 plus x to the 4. So we substitute back. And then we are finally done. And this is u substitution. Any question? Was any part confusing for any of you? No question? Okay then, let's do one more. Oh wow, Ziad. I hope you did see the email. Then you didn't have to go all the way there. Let's do one more together. First step, let's rewrite square root of 4 minus x squared, and then x dx. Can you guess what is the u here? Perfect. The inner function, 4 minus x squared. So du is negative 2x dx. So you can see x dx, but we don't see any negative 2 anywhere. That means we divide both sides by negative 2. So we get x dx is du over negative 2. And then we substitute square root of u, and this thing is du over negative 2. Negative 2 is a constant, so we pull it out. And we don't want radical sign, we want exponent number. So it's u to the 1/2 du. And then we can use the power rule because it's a number, not 1. Or the substitution work only for, so the power rule works only for, so the power rule works for everything else except 1. If your power is 1, then you cannot use power rule. So we add 1, we get 3/2. So u to the 3/2 when you add 1, and then we divide by 3/2 means you're multiplying by 2/3 plus c. But here 2 on the numerator, 2 on the denominator, they cancel out. So we get negative 1/3 u to the 3/2 plus c. But we cannot stop here because we don't know what's u. We were not given u. That means we have to turn it back into whatever was given to us. We are given 4 minus x squared. So I rewrite. Any question? Did you guys understand what I did? Nobody has any question? Thank you, Katie, for responding. Control Z. Okay, now the same thing, but this time, this time it's definite interval, not indefinite. So same process, same everything. The only difference is once you find your antiderivative, then you replace with your limits and get a number. And yeah, can you guess what is our u here? Yeah, we're going to do a few more examples together, and then you're going to do a lot by yourself. So who can guess what's u here? Good job, Lucas. 1 plus x. That means what is our du? Derivative of 1 is 0, and derivative of x is 1 dx. So in other words, du is dx, right? So I like to rewrite this so that I can see things. 1 over square root of 1 plus x, and then dx. So we get 1 over square root of u, and this dx is du. And then what? How do you find the antiderivative of this? On the left page, we found the antiderivative of square root of u. But on the right page, it's 1 over square root of u. So how do you find the antiderivative this time? Any idea from anyone? Come on, guys. If you know, how do you find the antiderivative? Good job, Carrie. Thank you. Yep, we rewrite using exponents. So it's u to the negative 1/2 du. And now we can easily find the antiderivative by adding 1. So we get u to the 1/2, and divided by 1/2 means multiplying by 2. Plus c. Oh, sorry, my bad. For definite integral, we don't have to write plus c because it's definite. So we cannot stop here. We have to write as 2 1 plus x 1/2, which is same as 2 square root of 1 plus x. And we need to evaluate that with x equals 0 and x equals 8. Okay, for definite integral, we don't write c. Instead, we replace. I mean, sometimes we do write c if we have enough information to find out what is c. If we don't, then we leave it alone. We don't write it down. So we have 2 times square root of 1 plus 8, and then minus 2 times square root of 1 plus 0. So we substitute the upper limit first and then the lower limit. So we get 2 times square root of 9 minus 2 times square root of 1. That gives us 2 times 3 minus 2 times 1. So we have 6 minus 2, which is 4. My 4 looks like 9. Let me fix this. Any question? You cannot substitute the limiting value for u because the limiting value is given only for x, not u. So if you want to substitute here, you have to find what would be the upper and lower limit for u with the given information. Like when x is 8, what is your u? When x is 0, what is your u? And then you can substitute here. I find it troublesome, so I don't like using that. Instead, I resubstitute the original function and then use the given limit. I always did that. I never liked changing my limits. Any question on this example? No question? Okay, let's do one more together. Something with trigonometry. We have two functions. One is cosine, one is sine. Who can guess what is u? Anybody? If only x is u, then you have cosine u to the 19th power sine u. We still have the same problem. If the entire thing is u, how can you find this? Remember, if u is something which derivative is already given. So if u the entire thing, where do you see the derivative? So you cannot be the entire thing. And then you have two choices, either sine and cosine. Now, which one is correct? Is it sine or is it cosine? Yep, it is cosine. It cannot be sine because sine's in. Remember, here I said du has to be alone, not inside any function. So if you let u is sine, then your du is cosine. That means this becomes du to the power 19, which doesn't make sense. Du cannot have any power. It's a symbol. It cannot have any power, cannot be inside any function. So now our correct u is the inner function. So you see this is inside and outside we have the 19. So u is always the inner function of the composite function. So our u is cosine x. So du is derivative of cosine is, do you remember? What's the derivative u? Sorry, what's the derivative of cosine? Negative sine. Perfect. Negative sine x dx. but we see only sin x dx. We don't see any negative given to us. That means you have to divide both sides by negative or -1. So negative du is sin x dx. So we rewrite inside we have u, outside we have 19, and this entire thing here is negative du. Now we don't want the negative next to the du, so we bring it outside and we get negative antiderivative u to the 19 du. And now it becomes a simple polynomial. So what's the antiderivative u to the 19? U to the 19 is what? U to the 20, and then I divide by 20. Good job, Rakam. And we add a constant. But we cannot stop here because they didn't give us u in the original function. So we cannot give them the answer with a u. So we rewrite negative cosine x power divided by, or if you want, you can write negative cosine 20 to the x over 20. For trig function, the power is interchangeable next to the trig function or after the trig function. They're the same thing. You can put it outside after the entire trig function, or you can put it only on the trig function. It's the same thing. Any question? Are you guys sure nobody has any question? Okay. Think about the next one. No problem. If u is sin x, du is cosine x dx, right? Now look what is given here. Cosine x whole thing to the 19 sine. So our first problem is lying here. Du is next to the cos, so d. But what do we have? Cosine x is inside 19 and dx is here. We cannot put dx inside 19. It doesn't make sense. Second problem is here. This cosine x du with the 19 power. But du cannot have any power. It's the symbol. Good. That's how I figure out actually which one is. That's why I said, like, look at the du. If you know you see du, that means you can figure out your u. Okay, next example. Which one is u? Which one is a good candidate? Good job, Musfika. It's the inner function. See, this function is inside, and u is actually always the inner function. So if you don't see it right away, no problem. Do trial and error. Think about, can u be sine? if u is sine x to the 16, du has to be cosine x to the 16, and then derivative is 16 x to the 15 dx. We see this, but we don't. This cosine is not given to us. That means u definitely cannot be sine. Whatever is u, its derivative has to be given in the function. So sine cannot be u. And if you think u is x to the 15, look what happens. Du is 15 x to the 14 dx. The problem is you don't see an x to the 14 given to us. That means u cannot be x to the 15. U has to be something which derivative is already given to us. So both sine and x to the 15 fails. Now let's see what happens for x to the 16. If u is x to the 16, that means du is 16 x to the 15 dx. And now look, we see this. X to the 15 dx, x to the 15 dx. It's given to us. The only thing is not given to us is a 16. So we divide both sides by 16 and we get du over 16 is x to the 15 dx. So if we substitute, we get sine. Inside we have u, and this thing is x to the 15 dx. Sorry, my bad, what I'm doing. This thing is du over 16. So see, our u is given, also du is given. So you pull out this 16 because it's a number. So 1 over 16 antiderivative of sine u du. In other words, they are just telling us find the antiderivative of the sine function. So 1 over 16. What is the antiderivative of sine? Which function has derivative sine? Do you guys know? Antiderivative of sine? Negative cosine. So it's negative cosine u plus c. But u is not given to us, so we need to replace that. And negative, we cannot put it in the middle. It looks weird. So we put the negative in the front. Negative 1 over 16 cosine. Instead of u, we write x to the 16. And now we are done. If you take the derivative of this function, you'll see it becomes the original function. I mean the function given to us. So you can actually always check your antiderivative by taking the derivative of that. Let me check the derivative, okay, just to show you. Check. So if you take the derivative, it's 1 over 16. Derivative of cosine is negative sine. So negative sine x to the 16. And then you multiply by the derivative of x to the 16, which is 16 x to the 15. And then derivative constant is 0. So let me show you here real quick. We have negative 1 over 16, negative sine x to the 16, and then 16 x to the 15. 16 and 16 cancel out. Negative and negative turns into positive. So we get sine x to the 16 and x to the 15. See, this thing and this thing are the same thing. The dx comes with the antiderivative symbol. Antiderivative and dx or dt or whatever, they're together. It's like parentheses. They're one, the left side is the left end, and the right side is the right end of the parentheses. So if you take the derivative of your answer, you know it's your original function. Now the next one, if you look at the next one, you'll see something kind of different. Let me erase all of this. So what do you think our u is here? We have x over square root of 9 minus 3x. Which one is u? Oh, you guys are smart. Cool. Definitely it's the inner function. 9 plus 3x. That means our du is 0 plus 3dx. In other words, 3dx. We see a dx, we don't see a 3, so we divide both sides by 3, so we get du over 3 is dx. So if you substitute, you get 0 over 9 square root of u, and then this dx is du over 3. See the problem? What do we do with this x? Yep, we need to solve for x from here in terms of u. We have u, we have du. The only thing we don't have is x. What is x? So we come back here and we solve for x. 9 plus 3x is u. So we subtract 9 from both sides. We get 3x is u minus 9. And then we divide both sides by 3. So x is u minus 9 over 3. Or in other words, let me rewrite. It's u over 3 minus 9 over 3. But 9 over 3 is 3. So let me simply write 3. u over 3 minus 3. So this x is u over 3 minus 3. It looks weird, but at least we have everything in our function. We can rewrite everything with what I was saying. We could replace everything in the original function with something. So we just have to rearrange things to make it look nicer. So we have 0 over 9. And this thing we can rewrite as, well, actually, let me keep this. Never mind. Yeah, we can multiply by that. Never mind that. X is u minus 9 over 3. U minus 9 over 3. And this entire thing is the numerator. So we have u minus 9 over 3. And from the denominator, no, I'm not going to change the limit because I'm going to substitute after I switch my u back. So we can bring our denominator into the numerator. We get u to the negative 1/2. And we have du over 3. Why I did that? Because see, now we can easily multiply this 3 with the 3, and they will be outside of our integral. So 1/9 antiderivative of 0 to 9, and then this thing du. Who can guess our next step? What can you do so that you can find the antiderivative easier way? Any idea from anyone? We cannot take the antiderivative here in this form because it's a multiplication. This times that. And there is no multiplication rule of antiderivative. Like the product rule for derivative, we don't have any product rule for antiderivative. Multiply out. Good job, Ellen. We are going to distribute this u to the negative 1/2 to this binomial. So we get 1/9 antiderivative of, so we get u to the 1 times u to the negative 1/2 minus 9 u to the negative 1/2. So u to the 1 and u to the 1/2, in multiplication, we're supposed to add the powers. So 1 plus negative half gives us positive half. So in the first part, we get a simple u to the 1/2 power. And in the second part, we get 9 u to the negative half power du. And now we can find the antiderivative easily because these are single variable. So 1/9, and then we add 1 to both. So the first one becomes u to the 3/2. We divide by 3/2 means multiplying by 2/3. Minus 9 u to the 1/2 plus 1 gives us positive 1/2. And dividing by 1/2 means multiplying by 2. And then plus c. You can put the plus c inside or outside. So if you want, you can distribute the 9. We get 2/27 u to the 3/2. This is definite integral. Yep, I know. And instead of 3/2, let me rewrite this so that we can easily evaluate. So square root of u cube, this is what 3/2 means. Minus, we have 1/9 times 18 square root of u plus c. So 9/18, this becomes 2. And let me also change them back now. Oh, why I'm writing plus c? My bad. Let me change them back. So we have 2 to the 27 square root of 9 plus 3x whole thing cube minus 2 square root of 9 plus 3x. And since we changed them back, that means we can evaluate using our original limit. And that's why I didn't write, I erased my plus c. Oh, I didn't see you writing Ellen, sorry, my bad. Definite integral, yeah. Thank you for reminding me, Ellen. I didn't see that before. Okay, so all you have to do is now hard work, algebra. replace and simplify. So we get 2 over 27 square root of 9 minus 3 times 9 whole thing to the power 3 minus 2 times square root of 9 plus 3 times 9. So this is what we get when we substitute 9. And then we subtract after we substitute 0. So when we subtract, this middle sign will turn into positive. So I get 2 over 27 square root of 9 minus 0 to the 3 power, and then plus 2 times square root of 9. Wait, why I have plus and minus? This is plus. And this becomes plus 0. Ugh. Don't get bored. You're going to do what is, oh yeah, never mind. Okay. So we get 2 over 27 square root of 9 plus 27 whole thing cube minus 2 times square root of 27 plus 9. Oh, I forgot my 9. 9 plus 27 minus 227 square root of 9 cube plus 2 times square root of 9. 9 plus 27 is 6. So we get 2 times 27 square root of 36 cube minus 2 times square root of 36 minus 2 over 27 3 cube plus 2 times 3. Now we have 2 over 27 6 cube minus 2 times 6. And a 27 and 3 cube, they cancel out because 3 cube is 27. So we get minus 2 plus 6. Did I make mistake anywhere? Two over 27. And then 9 cancel out. So we get 2. 2 over 27 and 2. So 6, 6, 6. We can divide 3. 3 goes to 9 times. We have 3. We have 2. Then 9 goes to 36 4 times. No. So yeah, 6 cube is divisible by 27. Wow. So here we have 2 times 2 times 4. So 8, no, it's 16. 16 minus 12. From here we get plus 4. So 16, 20. 20 minus 12 is 8. Oh. In other words, the area under this function from 0 to 9 is 8. I think this will be easier if we can just find out what is square root of 9 plus 3x when x is 9 and when x is 0. If you find this out separately, then we don't have to write all these things over and over. We can simply use a single number for that. Yeah. How come I didn't think of it before? My bad. Any question from anyone? Good news, I'm not going to put this type of question in the exam because it takes time. But I believe you have this in the homework and probably also in the quiz. So it's good to know that U substitution, not always you write U equals something. Sometimes you also have to rewrite your X in terms of U. So U substitution works both ways, with U and also with X. Now, if you don't have any question, here are the questions you have. Try them. 1, 2, 3, 4, 5, 6. Wow, I have mostly trig functions. And most of them are from your homework. So if you do them here, it means you're doing your homework. Try them. I'm here. Let me know how I need help. And 15 minutes. After 15 minutes, I'm going to start going over them. Let me take the attendance now. It is 4:23. Kimberly?
Here.
Okay, Kerry is here. Judith?
Here.
All right, Mac?
Here.
Okay, Ziad? He? Okay, Ziad. Chi? I don't see Chi. Jocelyn?
Here.
Okay, Lucas? Are you still there?
Yep, here.
How are you feeling, Lucas?
Good.
Good? Logan? Logan, are you there? Ellen?
Here.
Okay, Mospika?
Here.
Okay, Nick? Sanzim?
Here.
Ian? Raka?
Here.
Ella?
Here.
Apollo? Apollo, I saw you before. How come you're not here now? Wow. And Andy? Okay. So try these questions. These are not bad. IJK, they're a little bit tricky. But if you can catch the trick, it's fun. Okay, Logan, no problem. I marked you present. I saw you wrote it down here. Let me know, guys, if you need any help. Let's see how many you can complete in 15 minutes. Apollo, what happened? Today, are you also in school? I mean, at Hunter. Are you at Hunter or you're somewhere else? Oh, wow. No wonder you're not talking today. Usually, you're always answering questions. You're just like, oh, what happened to him? Okay, no problem. You have all the questions here, so before you see the solution at home, try to do this question by yourself and then check your answers, check your solution with the answers you're going to do later. No problem. Hey, how come you're so late? I marked you absent because I already called the name. So let me mark you present now. How come you're late, Chi? What happened? Oh, okay, I see. No problem. Wow, Ellen is already done. Cool. Okay. Okay, no problem. And let me check them real quick. E, D, so you have one time. Yep. And the next one is what you actually don't have to type if you don't want to. Let me show you the answer. You can check. And if anything you don't get correct, you can check by yourself or you can tell me. I can see what did you wrong. 1/28, 140 to the 7. So guys, you don't look at the answers because IJK, this should be some, let me move my page again. IJK should be some interesting question, some tricky questions. If you see the answer, you can already see your U. So these three, they look like they have same U, but they don't. And it's tricky to find the U here. So did you find anything else besides forgetting C, Ellen? Anything else is wrong or not correct? Great. Do I have anything else to do? Let's see. No. So what time is it now? So we have 5 more minutes and then we'll go over. Yeah, that's all actually for today. And in our next class, we are going to do 7.1, which is, I forgot, area between curves or area under curve, something like that. I forgot what that is. Well, you can try doing the homework if you didn't do them yet. Between, okay. Between curves. So if you want, you can actually do the homework on them. Never mind. You can do the homework on these. And most of them are here actually. If you do them here, that means you're doing the homework already. Cool. Wonderful. So volume. I'm thinking to put the quiz for volume optional, because from my experience, I've seen that people don't understand volume much, and the quiz question or the homework questions in volume are much little bit harder for them. So I will make the last quiz optional. If you do, you get extra credit. If you don't, it's fine. But for you, Ellen, you definitely should try it. You like challenging questions, so yeah, you should take chapter 7 quiz. But for others, I'll make it optional. Oh, and I also posted a review sheet, guys. Did you guys notice that? I posted a review sheet on Brightspace. I forgot to tell you that. Oh, actually, I did tell you yesterday, I think. Man, I'm forgetting what I told you yesterday. So I posted the review sheet, and our exam will be, today's Wednesday, right? Our exam will be not next week, but the following week, Monday on 5th. So 5-5. 5-5-25. Oh, cool. 5-5-25. 5 times 5 is 25. So exam 3 will be on 5-5-25. What an interesting date. Cinco de Mayo? Oh, yeah. Cool. Yep. Are you guys done with these 6 questions? Besides Ellen, who else is done? Anyone else? Okay, Musfika is almost done. How do you do L? Think about what is your U. You have to pick U so that the du is also given. So can U be cosine? That means you have to have a derivative of cosine is given. Do you have the derivative of cosine given? This type of question you should ask yourself. How about 2 more minutes? Will you guys be done in 2 more minutes? Or do you need 5 more minutes? Which one? Okay, 1 more minute. And then we'll start. And this time, I'm actually going to call you name to tell me what is you. Ready? 1, 2, 3. Here we start. You can check your work. I'll give you 1 minute. And then it will start. See how many of you got correct. Okay, let's start. and D. What is U here? Which one is U? In the first question. You don't have to write it down. You can unmute yourself and just tell me. Are we there, Andy? No. Okay, Katie, you go ahead. What did you pick your U in this question? Which one is U? Okay, Jocelyn, go ahead. Everything under the radical? Yes. So Jocelyn, you can tell me du. So 26x plus x squared. If that's the true, if that is u, then what is du, Jocelyn? What
Oh,
can you do?
du.
Oh, okay, never mind. Never mind. You said you wanted to 8.
Yeah.
No problem. So du, what is our du here? Carrie. Derivative of 26x is 26, and derivative of x squared is 2x dx. So do you see this in the given function? 26 plus 2x dx? We don't see that, right? So what can we do so that we can see our derivative is given into the function? Factor. We can factor out 2, or we can simply divide actually. We can divide everything by 2, and we get du over 2 is 13 plus x dx. So now we can see everything. Square root of 26x plus x squared, and then x plus 13 dx. If we put this together, we can see our du. So antiderivative square root of u, and this thing becomes du over 2. So 1/2 u to the 1/2 du. And you already did it many times. It's u to the, we add 1, u to the 3/2, and then you multiply by 2/3 plus c. The 2 and 2 cancel out, so we get 1/3 u to the 3/2 plus c. But we cannot stop because u is not given to us originally, so we rewrite as 1/3 instead of u to the 3/2, we write 26x plus x squared, whole thing to the power 3/2 plus c, which is same as this one. Any question? Okay, Jocelyn, the next one. What is our u?
Wait, I thought h was the like the one with antiderivative 1 over 1 plus 4t.
Okay. Somehow this one, right?
Yeah.
Yeah.
Okay, so u is 1 plus 4t.
1 plus 4t.
And then du is equal to 4 dt.
4 dt.
And then you divide 4 by both sides. So then du over 4 is equal to dt.
Perfect.
And then you substitute 1 over u to the power of 8 times dt over 4.
And then du over 4.
Yeah, du over 4. And then take out the 1/4 from the antiderivative. And it's just 1 over u to the power of 8 du. And then you take the derivative of u, so it's
taking antiderivative, not derivative.
yeah. So then it's 1 over 7 u
Nope.
to the power of 7.
See, we don't know how to take the antiderivative of a fraction. So what do? We rewrite as a negative exponent.
Okay.
Well, at the end, maybe we get the same answer. I didn't actually realize. So if you actually first we're supposed to rewrite. If you rewrite, then what do you see? What's the antiderivative?
Then if we take the antiderivative, we add 1, so then it's u to the power of -7 over -7. And then
Plus C.
plus c, yeah. And then you substitute, or no, you do the inverse, so it's -7. Yeah.
28. And then 1 over u to the 7 plus C.
Yeah. And then just substitute for u 1 plus 4t.
1
And then
plus
plus C.
4t to the 7 plus C.
Yeah.
And we can put this together because they're on the same denominator.
Okay.
Good job. So we did the next one, and now here. Why are my numbers so messed up? Go ahead, Sanzim. What is
So for this, u would be tangent of x, right?
Perfect. Then
du would be secant squared x.
Secant square x dx.
So like if you rewrite the function, you'll get the integral of u du.
Great.
And
So
then since we're integrating in this case, you'd have to do u squared over 2 plus c. And from there, you could just plug in the tangent of x over 2 plus c. And
then
from
if
there,
you want,
you
can put it inside.
Yeah,
So
I was gonna say that. Yeah.
Okay.
And you could
Great.
also like put 1/2 in front if you don't want to.
Right. So if you want, this is same as 1/2. My 2 looks weird. Plus C. All of these are correct. Good job, Sanzim. Any question from anyone on this? Okay, who would like to do the next one? Tangent square, secant square. Wow. Because the power rule says if we have x to the n, its antiderivative is x to the n plus 1 over 2. Sorry, yeah, n plus 1 over n plus 1. What did I say? Come on. Okay, who'd like to try the next one? Lucas, how about you?
Sure.
Go ahead.
So u will be tan of x.
E is 10 of x. So
Then you
derivative u.
be secant squared x dx.
Secant square x dx.
So then you can substitute that for du, giving you u squared du.
So we have u squared du.
And using the power rule, it'll become u to the third over 3 plus c. And then you can substitute tangent in for u, so it'll be u cubed over 3 plus c.
Tangent cube of x over 3 plus c. And this is same as 1/3 tangent cube of x plus c. They both are same. Any question? How about the next one? Who would like to try the next one? Next one is interesting. Very, very interesting. Who would like to try it? You know what? I was thinking of you. Go ahead. Secant of x.
Yeah, so u is equal to secant of x, and then derivative is equal to secant x tangent x. And then now you have u squared du. And then you just do u cubed over 3, and then you substitute back secant squared. Secant, I mean.
Slow down. Let me write. So we have secant x, tangent x. But we see tangent x alone and 3 of them. So we need to, oh man. Let me write here. Okay, sorry. Sorry for the trouble. Let me close it and reopen it. No, which one I'm pulling out? That's supposed to pull out this one. Okay. So since we are given 3 of the secants, so we need to break it down into 2 of them, and then secant x, tangent x, dx. Because secant x, tangent x, dx is our du. So we do u squared and then du. Okay, Alan, go ahead. And then what?
So that's just u cubed over 3.
U cubed
plus c.
over 3 plus c.
And then you substitute secant x, secant cube over 3 plus c.
Secant cube of 3 plus c. Good job. That's what I said. It's the interesting one. Because you have to break your 3 powers into 2 powers and 1 power. needs help? Is there anybody who did not understand what we just did? Anyone? No one? Okay, then the last one. Who would like to try the last one? What is our U? How about Musfika? Would you like to try this one?
Yeah, sure.
What is your U?
So I believe your U would be pi t over 2.
Perfect.
And then du would be, this one I kind of had trouble with because
What is your variable here?
t.
Okay, so what's the derivative of t?
1.
1. So you have a coefficient pi over 2. So what's the derivative of pi over 2t? Pi over 2 is a coefficient, right?
Yeah.
And derivative of t is 1
Yeah,
dt.
so yes, yeah.
So its du is pi over 2 dt. But we didn't see pi over 2 given to us. So what do you do? We see only dt. We don't see any pi over 2. So we divide both sides by pi over 2 because we have to replace our dt with du. So this cancel out. We get dt is du over pi over 2. Or pi over 2 means multiplying by 2 over pi. So it's 2 over pi du.
Yeah.
So we come back here. 3 cosine and then pi t over 2. What do we write instead of that?
2 pi?
No, we write u.
Oh, u, yeah, sorry.
And this one is 2 over pi du. Clear? So we have 3 and pi over 2. These are numbers. We can pull them outside. We get 6 over pi antiderivative of cosine u du from 0 to 1. So what is the antiderivative of cosine?
Sine.
Sine. So sine u, and then we're going to replace not here in the next line. Instead of u, we write back our pi over 2t. And here we replace t with 0 and t with 1. So go ahead, what do you have then? 6 over pi, and then what? If you replace your t's, what do you get?
1 minus 0.
You always have to replace the upper limit first, and then the lower limit. So t is 1, right?
Yeah, will you get 6 pi?
pi over 2. We still have pi over 2 inside, right, as our angle. Pi over 2, and this time our t is 1, so pi over 2 times 1. And then what do? We subtract, and we replace the next quantity, the lower limit. Sine pi over 2 times 0. So we have 6 over pi. Here we have sine pi over 2, which is 90 degrees. And what do we have here? Pi over 2 times 0 is?
0.
0. Now we need to know what is sine pi over 2 and sine 0. How much?
Yeah, that's 1 minus 0, and that equals to 6 over pi.
6 over pi. And that's it. Oh, I say 6 over pi, right? Yep. Okay. Does anybody have any question on any of these? You definitely need to have more practice. So please do the homework as soon as possible before you forget the materials. And all of these questions, I believe almost all of them, not all of them, almost all of them are taken from the homework. So since we did many questions here, so in your homework, you just have to do few more questions. So try them and definitely try these again without looking at the solution. In our next class, we are going to do something different. We are going to go to chapter 7 and we are going to work with volume, which is a little bit different than what we did so far. But if you understand this better, then understanding chapter 7 will be easier for you guys. And that's all for today. We have completed our section 4.5. So we did 4.1, 2, 3, 4, 5. We did all 5 sections. Really? Let me see. I feel like we didn't do one section. 1, 2, 3, 4, 5. Oh yeah, we did. 4, 3. Oh, 4, 3, we didn't do 3.6. We missed that. We don't have to do that. And we have 4.1, 2, 3, 4, 5. Perfect. Any question? Comment? Concern? Anything? Nothing? Okay then. Again, thank you so much for being here. I really appreciate your understanding. We'll see each other again on Monday. Have a good week, rest of the week, and good weekend. Be safe. Don't sleep. I mean, not sleep. Don't fall down. Bye. Okay, Chi, no problem. Thank you, Kimberly.